Okay, so as we pick up with the chain rule here, you can use the chain rule to differentiate all kinds of functions, and if the outer function is a trig function, we're just going to follow the pattern of what the chain rule says. So for example, if we're talking about the sine function here, and we want to find its derivative and the inner function is differentiable, then we're going to say that the derivative is cosine of u times whatever the derivative of that inner function is. And you can just go ahead and make that assumption for the rest of them following their specific derivatives. And multiplying them by the inner function's derivative just like that. So not much surprise there. Let's take a look and see how that works. So don't forget the outside-inside rule, aka what you do last, up here at the top of this particular page. So differentiate the outside function f and evaluate it at the inside function, and then multiply by the derivative of the inside function. So again, repeating what we did in class on the first day we did this, f prime of g of x times g prime of x. All right, so if I wanted to find the derivative of these functions, I have to look and see which is the inner and which is the outer, just like I've been doing. So for this one right here, the derivative of the outer function is going to be a cosine because the inner function is this 2x. So dy over dx is going to be the cosine of 2x, and then I multiply it by the derivative of the inner function, which is just going to be that 2. And the only thing I can really do to clean that up is bring that 2 in front just for cosmetic purposes, and there's your result. Okay, so looking over here now at part B, the cosine of x minus 1, if I want its derivative, then I have to take the derivative of that outer function, which will be negative sine of x minus 1, and then multiply by the derivative of the inner function, which is just going to be 1. So this works out to be negative sine of x minus 1. Not too much trouble here. I hope you're finding this to be pretty easy so far. Tangent of 3x for part C down here. Again, pretty easy to do. The inner function is our 3x. So the derivative is going to be secant squared of that 3x, and then multiplied by the derivative of the inner function, which is 3. And again, cosmetic purposes, bring that 3 out in front, and that's pretty much what we've got right there. Okay, so this last one over here, part D, sine of x squared plus x, so have to be maybe just a touch careful here. The inner function is x squared plus x, so dy over dx is going to be the cosine of x squared plus x times the derivative of this inner function, which will be 2x plus 1. Okay, now I want to caution you, you can't combine these. You cannot combine these at all. And the reason why you can't combine them is because this part right here, the x squared plus x, that is part of the cosine function. And remember, it's locked down really tight. So cannot combine any further. So don't do it. All right, taking a look at the other ones down here at the bottom with the parentheses and the trig functions, it all depends upon the location of that power. So the cosine of 3x squared, if I were to put some parentheses around the 3x squared, then finding the derivative isn't so bad. The derivative is going to be negative sine of 3x squared. And then I multiply by the derivative of that inner function, which is, of course, 6x. It's about as far as you can really take that one. Okay. Now, take a look at this one right here on part B, and you'll notice, well, I've got two different functions going on. I've got a cosine of 3 times an x squared. Now, something fascinating to note about this is that the cosine of 3 is actually a constant. So we're pretty much subject to the constant multiple rule on this one. And I can just treat that as a constant. So dy over dx is going to be the cosine of 3. And then I have to multiply it by the derivative of x squared, which is just 2x. So really nothing much more that you could or should want to do with that. All right, one more page. All right, looking up here at the top, now that cosine of 3x quantity squared, you know, it might be a wise move to distribute that power first, just to make your job a little bit easier. Otherwise, you're going to be doing lots of applications of the chain rule. And we'll take a look at how that looks like in just a little bit. Maybe the next day we take a look at this. So the derivative with respect to x is going to be negative sine of 9x squared times 18x. And that is about, once again, as far as you want to take it. Okay? So for part D here, I'd turn this into a power of 1/2, just like I've done everything else to this point. Turn it into a power of 1/2. And now you can find its derivative much faster by using the power chain rule. So it's 1/2 times cosine of x to the negative 1/2, and then I multiply that by the derivative of the cosine, which is the opposite of the sine. And really, the only thing that can move is just this cosine of x. That's got to go downstairs because of the negative exponent. So this is going to end up being 1/2. And then I've got a negative sine of x over a cosine of x to the 1/2 power. So if I wanted to clean this up just a touch more, it would be negative sine x over 2 and a root of a cosine of x, because the cosine of x to the 1/2 power is just that square root again. Okay. Tricky one in E. This is one that gets a lot of students until they have it down. Look at the position of the exponent. It is now on the cosine. So remember, if I were to evaluate this, I'd have to do cosine first and then square it off. So that's a signal that I need to use my power chain rule first. So dy over dx is going to be 2 times the cosine of x. And you notice we lowered the power on that to be 1. So it really doesn't make any difference if you write that there or not. But what does make a difference is you need to multiply by the derivative of the cosine, which is the opposite of the sine. And the very observant in the room will note that this is actually a sneaky trig identity. It is negative 2 sine 2x when you simplify it. Trust me on this one. Okay? So that's what the final answer is going to look like when it's all said and done. If you didn't simplify it to that, I don't think I would complain too much. All right, now the last one here is we've got an example once again with an object that is moving along the x-axis, and there's its position given by a cosine function. Now if we want the velocity function, that's just simply the derivative of the cosine, or excuse me, the derivative of position. So x prime of t is going to be the opposite of the sine of t squared plus 1. And then I just simply multiply by the derivative of that inner function, which is 2t. And we weren't asked to do anything else, so that's all there is to it. Okay, that's what we've got for today, and we'll catch up with you soon.